Hello everyone. Today I'm myself, Dr. Gopal Keshyam and Dr. Shankar Ramurthy sir going to present our work on resource management in cloud computing with respect to its performance, titled Performance Management in Cloud Computing. The agenda of the talk is we'll be covering abstract, introduction, related works, performance management in cloud, and then analysis of system performance, conclusion, and then the references. So in the abstract, what we want to say is that in the existing research, in the existing study, we see that the resource adjustment decision-making process is linked to system behavior regarding resource utilization and application component. And the most essential requirement and restriction in cloud resource management, as well as workload and anomaly analysis approach in the context of cloud performance management, is what is the focus of our work. The related works are also studied from the recent articles from a peer-reviewed journal and conferences, with major methodologies in current studies ranging from data analysis to performance techniques. Finally, a list of open challenges is compiled, taking into account the identified gaps in the overall direction of the tasks under consideration. Now, we know that with the advent of cloud service providers such as Amazon and Google, we are getting to see a lot of expansion of cloud services. And the primary goal of these cloud service providers is to find more efficient resource allocation method so that they can be able to serve more customers. They can be able to manage the resource in the data centers very well, and they can be able to optimize the usage of the overall resources. In the papers that we have put in here in the references, we see that some papers, they provide a high level overview of specific data needs by talking about mathematical models and algorithms for extracting hidden information from the existing data. Whereas some references, they present a resource scaling taxonomy focusing on difficulties of distributed resource management, cloud resource management in the context of large web applications. Some other and most of the references, they categorize numerous scaling solutions for managing an application's resource requirement. So this is our proposed architecture in which we say that the performance management in cloud can be done in 4 phases. Initially, we need to make sure that the application that is running is monitored. We need to do the analysis of what kind of applications are running in and what is their resource requirement. And if we see that the performance is not going as expected, we need to plan for getting more resources, deploying more virtual machines, and then executing it in the real environment and ensuring that there is a seamless execution of the user's application. So this cycle continues from monitoring to analysis to planning to execution, and we have to monitor the performances of the servers that are there in the data centers. It could be database servers, application servers, or web servers. Also, the resource monitoring is to be done for the device and the tasks that are running in the devices, right? So this is the description of the 4 phases, starting from monitoring, analyzing, planning, and execution. So for monitoring, we have some useful tools. For example, top and IOStat packages are available along with Gangelia framework, which is in reference 5 given here. And analyzing is the analyzer module that is used for performance management is actually divided into 2 parts. One deals with the data preparation and the other one with performance modeling and analysis. The planning phase, what happens is the analyzer provides information about the current or future state of the system that is deployed. And in the execution phase, the execution module is the place where the system's execution of scheduled activities or tasks take place. We could be able to do some comparative analysis with respect to delay metrics on different clouds pertaining to Salesforce.com, Google App Engine, and Amazon EC2 with respect to platform as a service, software as a service, and infrastructure as a service. So we saw that for Salesforce.com, the CPU requirement was medium. That means they were able to take medium kind of delay, that means acceptable. For CPU the delay was higher, that means response time is low, and for RAM the delay was less, that means the response time is quick. That means RAM intensive applications can be run quickly in salesforce.com. Whereas for Google App Engine, if you see the IO and CPU applications, they've got lesser delays here, that means they get quick response time pertaining to IO and CPU. Whereas for Amazon EC2 pertaining to infrastructure as a service, that is I, A, and S. So for this we see that the RAM, for RAM intensive application the delay is lower, that means the response is quicker for RAM intensive application. Now there is an alternate approach to problem of performance management with respect to anomalous system behavior, which will be able to alert us well in advance as to where the system is going and whether it is going in the right direction or not. Now these are the open challenges. VM elasticity analysis. Now currently more in-depth examination of the properties of vertical elasticity is required, particularly the time sensitivity analysis for various resource types pertaining to CPU intensive, IO intensive, RAM intensive operating systems and hypervisors which manages the virtual machines. Dynamic algorithm in cloud also should be explored and should be looked into, because we know that the dynamic nature of the cloud environment and the applications are like needing the resources which keeps fluctuating with respect to CPU needs, IO needs and RAM needs. And then this is the comparative analysis with respect to the response time, migration time and scalability using different algorithm, which is genetic algorithm and colony optimization, throttle load balancing and active clustering. So through genetic algorithm we could see that the response time is less and migration time for virtual machines also is less and scalability also is lower. With ant colony optimization we could see that the scalability is higher. With throttle load balancing too, all the parameters are seen to be higher. That means the response time, migration time and scalability, everything is good, performance is better. With active clustering we get response time and scalability on the higher side, whereas migration time is on medium side. So the conclusion is that in this presentation, in this paper that we have worked out, we looked at various approaches to cloud performance management and the necessity for more complicated and automated procedures to handle the dynamism of environment is highlighted by identifying the primary limits and factors through open challenges. And we know that new potential for improving performance aware distributed resource management mechanisms have been offered with the rise of cloud computing and power of data analytics tools. These are the references that we have referred from top journals and conferences. Thank you for your attention.